going to be that time. Sit down time. Alright, so I mostly want to go through how to do this stuff in the calculator. So you should have your data in. That's what you should get if you've done it already, but you've only done it already. You don't have to have done it already. But before, well, yeah, okay, so everybody hit stats. You should get that menu. And then we want to calculate. So it's tempting to think it's two variable stats because we do have two variables, we have height and arm span. But we want to do a linear regression. We want to do 4. And if you notice, that's just like y equals mx plus b. There's just a instead. So what does that number represent? Slope. Slope is change in what over change in what?
Y over x.
Change in y over change in x. What does that number represent? Y-intercepts. What is true about the x value when you're on the y-intercepts?
It's equal to 0.
It's equal to 0. It's like 0, 10, 0, 70, whatever. So keep those two things in mind as we start going forward. Hit enter. And if you have my kind of calculator, hit enter. And you're done. And then some people's might show more data, some people's might not. I'm going to fix all that in a second. But does the other kind of calculator, should I go through how to do that one too? I don't know what it asks. So just put the L1 and L2, and everything else should be blank for now. And then you'll have to do that, and you should get the same. And you might not get the same. You might be off by like a little bit. That would just mean you typed in the number wrong. And like I'm not worried about that. So A is your slope. B is your y-intercept. So this equation would be 1.17x minus 11.8. Well, look at the top of the spreadsheet. It calculates the equation for you. It matches, right? Or pretty close if you type something in a little wrong.
Well, I have that.
No, it's not exact.
Yeah, on the spreadsheet it says 1.6.
Oh, really?
Yeah.
Okay. Whatever. That's just rounding. Alright, now we have to, so there's two more things. Does anybody's calculator show r equals and r squared equals? So I want everyone's to show that. So I don't know why it doesn't default to this, but we have to turn it on. So we want to hit catalog. Catalog gives you like all the things that are available in the calculator. And that is above the 0. So hit second 0. And then you get this menu. And we want to go to, if I go too fast, or are we all okay on the screen? We want to go to diagnostics and turn them on. So you can scroll. You could also hit like alpha and then the D, which is the X -1 button. And it'll like jump to the D's. You want to go to diagnostics on, hit enter, and then hit enter again. And it'll just say done, and now they're on, and you won't have to do that again. Unless like your battery's died and we have to reset everything. But otherwise it just stays. Does anybody need that? Like everyone should have that done now. If you don't, let me know and I can help you figure it out. Are we done? Okay. So now do the calculation part again. So stat, calc, linear regression. Do the same thing, and now it should pop up with r squared and r. So you should have 4 numbers on your screen at this point. If you don't, please let me know so I can like get you straight away. Everybody's got 4 numbers? Okay, get your sheet out, and we're gonna go to this page here. So number 7. line of best fit at the top, and I'm going to write it carefully. It matters how you do it. And we'll practice it more, but just for now, I'm going to write y hat equals, instead of y equals. Hat means predicted. So that line that goes down the middle is what, like, we expect things to happen. It's the average. It's what would happen over if you told me your height, I could look at that line and be like, well, I expect your armspan to be this. Does it mean it's actually going to be that? No, not every point's like right on the line. But the line tells us what we would expect or predict, and that's what I call it a hat. It's just like a little up arrow. That's what that little up arrow means. It means predicted. So if you want to make a note of that, that little up arrow means predicted or expected. We can't say y equals because it's not true that every y value is on that line. We expect it to be on the line. But some people have bigger arm spans than height. Some people have bigger height than arm spans. Alright, and then I'm going to say 1.17x minus 11 let's say minus 11.85. Do we see where I'm getting that from? 1.17 is your a, like in front of the x, and then your y. But if you put this equation, even though you put the hat, you're kind of proud of yourself. You're on the test, you're like, oh, I remembered the hat, that's good. You would lose, this would be like a 2-point problem, and you would lose one of the points. So you'd essentially fail this problem. Everybody tell me what I'm missing. The other hat. What's the other hat? The other hat. No, there's no more hats. When I ask you to describe data, or let's say to describe data, or answer a question, what am I always like trying to get you to include? When you did graphs, what did I make sure Todd trying to get you? Title, label, context. So if I just see this, I don't know what it's about. Like, what does X represent? What does Y represent? So after this, you got to go, oh, by the way, X equals height, and y equals arm span. So that's like labeling your graph. It's like including context in the problem. You're telling the person, because they would call that like a naked equation. Like, what are you talking about? I don't know what that is. Now you've like put clothes on it, I guess. Okay, so let's use it a little bit. Number 7, if a student had a height of 180, what is their arm span predicted to be? So our predicted equation is 1.17 times x minus 11.85.
Do we have to adjust the 11.85?
What do you mean adjust it?
Because, like, we probably don't have to change the 1.17. We have to change the 11.85 because that's in inches.
I just noticed that it's in freaking centimeters. That's what you're talking about, right?
Yeah.
I just saw that. So what is it, 2.2 centimeters per inch, I think? We're going to turn the 180 to inches. Is it 2.2? 2. Alexa, how many centimeters are in an inch? I think you're right.
1 inch is 2.54 centimeters.
Good job, Angie. So 180 divided by 2.54, this is 70.866 inches. Sorry, Hobbs, I kind of looked at you like, what the hell are you talking about? But it was actually me that didn't know what the hell I was talking about. So what do you do with the x? Or what do you, sorry, I just gave the answer. What do you do with the 70.866? Plug it into the x because x represents height. So y equals 1.17 times 70.866 minus 11.85. So I get 71.06. Agree? That's it? So what that tells me is if I went to 71 on the, or what is it, 70.866 on the x-axis, so down here, and went up, it's the value of the line. It's the value of what we'd expect. It's the predicted value. So these two people here, were they above or below what we'd expect? They're above, and that would be called a positive residual, which we'll get into down the road. This person here was like below what we'd expect. But what we we just found is the predicted value. So we found the point like on the line. But I could ask that, like, you know, we could practice. I could be like, what if line is 50 inches? What if line is 30 inches? But like, that's fine, right? Just plug it in, so we do it. I think. For backside, are we good? I mean, we'll do more down the road anyways. All right, what does the slope mean? This is a harder one. So slope, I'm going to write out like my entire thought process. You can pick up or leave the parts that you want. Slope is the change in y over the change in x. So that triangle means delta, that means change. That's why you get like Delta faucets, Delta airlines, because they want you to think they're always like changing and adapting to the times, the new technology. So it's just change in y over change in x. Well, in our problem, what does y represent?
Span.
So that's the change in arm span divided by the change in height. And our slope is, sometimes it's a fraction, but in this case it's not, so I'm going to make it a fraction. What is our slope? 1.17. I'm going to make it 1.17 over 1. And then the x is the predictor. So it's like the input, the independent variable. When I tell you the x, can you tell me the y? That's the point. So the x is like what's changing, and the y adjusts to that. So the way I'm going to phrase this, for each additional, you can just say each additional height. That sounds terrible, because it's really like each additional inch in height. But I'm just trying to keep it like simplified for now. For each additional height, so an additional height is 1. Like I'm just saying, when this goes up by 1, we expect, that is an absolutely essential phrase. We expect arm span to increase or decrease. Increase, how do we know that? Positive. Increase by 1.17. Instead of we expect, you could say we predict. Or you could say on average. Those are all like similar phrases.
Do you have to say we expect, or can it be like just
You want to expect like on your own, not the rest of us. I expect. That's okay. That's how you're asking?
I'm just like asking as long as you have the word expect.
Yeah. You can be like Elias expects, as long as it says expect. Yeah, question on that? Okay, y-intercept. So I asked you before, at the y-intercept, what is the x value? 0. So we basically got a point, 0, comma, and what is the y-intercept? Negative 11.85. So we've got this point, that's x, that's y, and we've got to interpret it. So remember, x is like the starting thing. That happens first, and then y reacts to that. So this would be if someone had a height of 0, and notice it says, does this interpretation make sense in the physical world? And it's not going to, but we're still going to interpret it. If someone had a height of 0, again, we expect the arm span, Elias expects the arm span to be negative 11.85. So that's just straight up interpreting what that point tells us. Don't worry about whether that makes sense or not yet. So when x is 0, this is the y-intercept, and you're just writing that out. And again, the we expect has to be there because it's not necessarily true. It's just what we expect based on our line. And then does this make sense in a physical world? Have you ever met anyone that's 0 inches tall with a negative 11.85 inch arm span? You have?
Sister?
I don't even know what to do. Does it make sense? No. Unless you're gutter, apparently.
9.2. Yeah,
I don't know.
Okay. Tomorrow I'm gonna have you guys play this. Today we're gonna play it together because we don't have that much time left. Correlation. Correlation is represented by the letter R. R can go from -1 to 1. -1 would be a negative slope, and every single point is perfectly on that line. This would be R equals -1. Leave a space if you're writing this down. Leave a space here because I'm gonna make another one. R equals 0 would be there is no relationship at all. Like this is just random. Like interestingly enough, at this school, if you grab grade point down here and SAT score up here, this is like what it looks like. There's like no relationship between, which makes no sense to me at all. But like grades don't have any effect on your SAT score. It's basically what the graph. Okay, so then skip 1. R equals 1 would be a perfect, and I don't care what the slope is, they just all would be on the exact same line. And then now I'm kind of guessing. But R equals -0.5 would probably be kind of like this. Like you can tell there's a downward pattern to that, but it's definitely not perfect. Does that make sense? The idea of getting that there? Perfect to be -1. Like the less perfect you get closer to 0. Same thing the other way. Perfect to be R equals 1. R equals 0.5 would probably look something like this, where, you know, it's going up, I can tell that, but it's definitely not perfect. And it could be anything in between. It could be 0.7, 0.2, negative point, whatever. This will be on a multiple choice part, unless you have the data to calculate it. If you just get a graph, it'll be multiple choice. And the answers will be very spread out, so you're not going to have to pick between like 0.5 and 0.51 or something. But I just want to start showing you this, and tomorrow I'll give you a chance to play it on your own. But, so this is, first of all, positive or negative? That's positive. That's pretty strong. They're not perfect, but, alright, someone raise your hand, give me a guess. Carter, what do you got? 0.8. So it is 0.93 is the true R. That's pretty close. Next. You think it goes up? I think 0.1 is decent. 0.26 is stronger than I thought. 0.5? 0.6?
We have one heart left. We gotta be careful about this. Oh, we gained a heart.
And a heart.
What a clutch. Okay, that one's
Why are these all positive? What is it? You saying 0.72?
Yeah.
Why? I would be freaked out if you were right. Why are these all negative? So anyway, I just wanted to get that like in your brains before Monday. We'll keep going on Monday. You're done.